Hi guys, today we're going to talk about Fluke morphology. So here is the general body plan of a fluke. We discussed last time that they lack a specialized respiratory system, so they don't have lungs or something like that. They just diffuse gases. They don't have a skeleton, and instead of that, they really have kind of like a cuticle that helps to keep everything in. And they also don't have a circulatory system, such that we do with veins and arteries. Instead, they work much more similarly to how a hot tub kind of just swishes around. Um, so this is kind of dated, but this article down here is where I got this picture from. And so it says, except blood flukes, trematodes are hermaphroditic. Being a hermaphroditic parasite is really beneficial because you can reproduce super duper easy. And so what it means is that general flukes, have both male and female parts. So they have testes and ovaries and can make a completely fertilized egg sac and put that into the environment. Blood flukes, on the other hand, have like external parts. So they have an external male part and external female part. So they need to actually have sex with other blood flukes. So they call this being bisexual, but I feel like you still have both the male and the female parts. So maybe it's still hermaphroditic. I guess it depends on the specific definition you use. But yeah, so blood flukes have a slightly specific different body plan than most of the parasitic nematodes that we will be discussing. Sorry, trematodes. So again, this is what the general form is, but it's hard to include a bunch of different species into one simple picture. So they all kind of look a little different. So first, we're going to only look at a few important parts to be able to clearly identify. So the oral sucker, so they're parasites, so they usually need to attach onto the host somehow. And most of them, so here it notes that there's at least one. And these other ones, I believe this is a blood or liver fluke. Yeah, no, I think this is blood fluke. And these are more of the general body shapes that you'll actually come across. But these are both parasites too. So they have two oral suckers, so one at the end and one underneath. So that's very interesting. And this one also has two, so one right there and then one in there. Next is intestines. This is great because worms are super amazing for evolution because they have an area where they eat and then a different area where they excrete instead of sucking it in and spitting it out. This is great for us because we also have this message. And so here you can see where it comes in, the intestines along the side. These flukes are a little harder to see. They have these little different intestines here that are like branchy. But again, over here you can see exactly where the intestines are. They're not labeled, but they're very much more prominent and easily identifiable with this general body plan chart. So the male and female parts, they differ a little. So here they look exactly the same. This is a blood fluke, and on here it was only labeled the ovaries. I'm not quite sure if it does have testes or where they might be, but looking at the ones you'll encounter more, so you have the ovary, and that comes before the testes. And so ovary, and again before the testes. Here is a branched version of the testes, and here's a lobed version, like maybe here. This is a little different than, so here we have the testes before the ovaries, so that's interesting. And And then lastly, the uterus. So here it is very basic. It is just simple, so you can see it, probably so you can identify more of the pieces. The uterus on this is this huge black mass, and then over on these flukes, it's these different styles of branching or coiled dark spots here, and they come before the sex organs. And again, this one comes before the sex organs, but here they're all kind of mixed in together. And that's because maybe they might not for all species. So here we're going to try to label some ourselves, starting with the oral suckers. Give you a second to think about it. Where might they be? So here's for the first one, second one, and these are just so they're very easy to identify. And then you can see a second sucker on this guy, and then down here on this one. The bottom one I think is actually very difficult to identify, so I don't have too many pieces identified on it. So the respiratory system, where do you think the respiratory system is? If you said that was a trick question, you're correct. They don't have a respiratory system. They work more like hot tubs. They don't have things like lungs. So their testes and ovaries, where might that be? If you can find where the oral sucker is, you know where the anterior part of the parasite is, and posterior. So you should be able to figure that out. And the testes are here. This might be the ovary for that one. That's what I'm thinking, but I didn't label it. And then the blood and liver flukes down here. That one's easier to see, but C is easier to see, D is a little bit more difficult. So next is the intestines, which are very easy to see for the first two. The second one's a little darker, but it's those two lines, those branching lines there. And then the blood fluke has all these wibbly wobblies. And the uterus. So before we said the uterus comes before the testes and the ovaries, the sex organs. So it's the big masses here. And then on the blood fluke, I believe it's this thing there. And the circulatory system. Where is the circulatory system? And again, they don't have one. They work like hot tubs. The respiratory system uses diffusion to exchange gas. So those are some main factors that you should be able to identify. We're looking at them under like a microscope or something. And oh yes, last time we discussed about the coelom. So flatworms are acoelomates, and that is defined as an animal whose central space is filled with tissue. It's mesoderm layer. No true body cavity exists. So the coelom is here. So that is the body cavity, and this here, which are flatworms, they don't have one. And so the coelom helps to give rise for it helps for digestion, and it also helps for like hydrostatic movement and for something for the muscles to have their own kind of space to grow in instead of just kind of the spongy mesoderm movement layer. So why would it be beneficial to not have a coelom? Well, it took me a while to figure it out, but I think it really just comes down to the size of the animal. Since they have a simple body plan, I think having less layers makes it more efficient for diffusion. So we have to have lungs to get in the circulatory system to exchange gases and chemicals, but the flatworms don't, and so they can just diffuse it along that membrane, and being smaller helps with faster diffusion. So that's it for today. I hope you enjoyed, and some morphology on flukes. Diane.